Hey, welcome back. So today we're going to be talking about the center mass for a system of particles. This is primarily for physics and AP Physics students. And the center mass is actually a special point. So it's important because this is the location where if all of the forces are applying on this one single point, it does represent what would happen to the object in terms of the acceleration of the object or the motion of the object. The other things that are happening to the object can be effectively reduced to being at one point. This is true for a system of particles as well, and so that's what we're going to be dealing with today. So let's define the center of mass. We're going to say the center of mass is the weighted position of all of the mass of the object, or all of the mass of the system. This is special because we can treat the center of mass as if it is where all of the forces are applied, and it will have the same effects as if it was a point mass. A point mass, we could say, is a mass that has its dimensions small enough and localized enough that you can effectively represent it as a point without it being a problem. So it's much easier to represent something as a point. If we have a system like this of 3 different points right here, we could come up with the center of mass. And the first application of this is if we just assume that all 3 of these were the same mass, like this all had 1 kilogram here, 1 kilogram, 1 kilogram over here, you could visually figure out where the center mass would be for these 3 particles in terms of their position right here. Well, it would be right about in the middle. And I created an easy problem to begin with because I want you to get the concept. But I'm going to show you how to do the calculations in another sense. So visually, this is going to be our center of mass. But how would we go about calculating that in a reasonable way? So up here, this is your equation that's going to be on your equation sheet. And what we're going to do is apply that in the x-axis. So let me back up for a second. This I right here doesn't mean initial if you use initial and final in your class. This means something like iterations or instances, like however many objects you have, like this one, and this one over here, is however many terms you have in the numerator and however many masses you have in the denominator. So if we take a look at this, this would be the mass times the position for the first object plus the mass times the position for the second object, and so on for as many objects as you have in the x-axis divided by the sum of the masses down here. So I put a ... to conceptually represent what we mean with this sub I right here. You can't just do this in the x, you also have to keep track of what's going on in the y, so that's what we're doing right here. And so let's go ahead and take this and plug in some numbers. So all of these have a mass of 1 kilogram just to make it super easy to begin with. And we have our x values here, so 0.5, 1.5, and 2.5 corresponds to this green, red, and blue x values. And I ran out of room here, so I'm going to put the answer right up here, and so the answer turns out to be 1.5 meters, which we knew. We could visually just check that and say, oh yeah, it's going to be 1.5 meters. The y would be a little bit harder to get right visually, so what we would do is still do the math right here. So we're just plugging in 1 for our mass for all of these, and the y values of 0.5, 1.5, and 0.5 again right here. We do the math and we end up with 0.83. So we could say our point is at 1.5, 0.83, which is right in the weighted center of these things. Alright, so that's how we would go about doing this in a very simple sense. Let me give you a more complex problem though, where our masses are not all 1 kilogram, where that's going to be 1, 5, and 3 respectively, so that's 1 kilogram, 5 kilograms, and 3 kilograms. If that's the case, I want you to think about where is the weighted average or the center mass going to be for the system of particles in reference to our original point. Is it going to be higher? Is it going to be lower? Is it going to be to the left or to the right? I want you to pick 2 directions and commit to them right now, please. Alright, so hopefully you're able to figure out, alright, this has 5 kilograms of mass, so this is much more massive than, say, this point over here, which means it's going to drag up our average to be higher than what it was, so it would be a positive y change. And over here, this 3 kilograms corresponds to the blue point, so that's going to drag the average center mass to the right a bit as well. So we could guess that we'll be up and to the right of where number 1 was, which represents the geometric center of the mass of the system of particles. Alright, so let's take a look. So we're going to go ahead and do the same thing that we did before. The only difference is this time we've got different values for the masses that we're plugging in here. And at this point, I just want to say, please be careful. It's easy to make a little error that'll throw off your problem. So I do the math. I ran out of room again. I'm going to go ahead and put my answer up here for x. And I do the math over here for the y. And I just have to be very careful with all of the terms that I'm dealing with, all of the numbers I'm dealing with. And then I can go ahead and put my answer up here as 1.1. And what that means is our average value for this center of mass is definitely higher. It's definitely in the positive delta y from what it was before, and it's a positive delta x from what it was before, because we're now applying the concepts of this having a greater mass and this having a greater mass as well, pulling the weighted average out of the geometric center that we dealt with. All right. Let's go ahead and see how to apply this for a tougher problem. So the tougher problem is going to be that, let's say we have my old pickup truck, and we're going to say this is 4 meters long, even though it's really not that long, but let's just roll with it. This is center of mass 1.5 meters from the front of the truck. So here's the front of the truck. The whole thing is 4 meters, and it's going to be 1.5 behind that. That's not exactly in the middle. If it was exactly in the middle, it would be 2 meters behind the front of the truck, right? And we're going to say we're going to put a heavy load somewhere in the back of the truck. And the question is, where should we put the load so that the combination of the truck and the load will have a center mass right in the middle of the truck? That's what we're attempting to do. So what we're going to do is start with a label. This we'll call our 0 points. And just because the picture is taken this way, we'll make this our 0 point, and our positive x-axis will make it to the left, which is the opposite direction of normal, just to make the numbers easy to work with. And I'm going to label this whole thing as 4 meters. Then I'm going to say, well, the center mass of my truck is going to be 1.5 meters behind that. And the center mass of the truck plus the load is going to be right here. So I can treat the truck as if its mass is located at that point. That's what we mean by that center mass. So let me show you how to work this out. What we're going to do is start with our equation. Because we have two terms, I'm going to simplify this and just have two terms here. I'm going to label these as truck and load. And then what I can do is think about, we're not looking for the entire center mass for the whole system. In this case, we're actually looking for the position of the load. That's what we want. As long as you can set that up and recognize it, then you can do the rest. But I'm going to show you the algebra. At this point, you should be able to handle this, though. We're going to multiply by this denominator here. We're trying to isolate for the XL. So then we're going to just subtract this term over. So that's what I've done right here. And then we're going to divide by ML to be able to solve for the position of the load. Now, I've run out of room, so I've labeled this as equation 1. I'm going to show you that on the next page. Same equation right here. Now, at the end of the problem, we're ready to go ahead and plug these values in. And I've gone ahead and done that. Just be careful here. It's easy to make a little mistake. But it's also important to ask yourself at the end, like, is the answer reasonable? Occasionally, people make mistakes. And if you get an answer that's like, 5 meters or something like that, then that would be a red flag that that does not make sense, that you must have done something incorrectly. All right, so we continue with the math, and the answer turns out to be 2.78 meters right here. So that's how you would go about doing this. If you have any questions or comments down below, let me know. I've done screencasts on basically the entire year of high school physics, as well as a lot of the concepts in AP Physics C mechanics. So if you want to see more, check the description below, and I hope you all have a great day. Take care.